So in this problem, what we're going to do is we're going to take a golf ball and we're going to drop it off and see how long it takes it to travel a particular distance. Okay? And then we're going to take it one step further than that. So what we have is we have a golf ball and it's over a very, very, very high cliff. I don't know the height of the cliff, but it's not really all that important. Okay? So here's my golf ball and it just simply drops. Okay? So first thing I need to do is I need to get all my information together. Now, it's another problem that appears to be on Earth. As far as I know, it doesn't say that it's not on the moon. Right off the bat, that tells me that the acceleration is equal to negative 9.8. Now, I'm going to simplify this by using 10, but remember this in the future. I mean, obviously, if you're taking a test, you want to think of this as being 9.8 and not 10. Oh, look at this. I even forgot units. I shouldn't do that. Also, what else do I know? I know that the distance that I'm trying to solve for is going to be 12 meters. So I'm going to say my final position is negative 12 meters. Now, why is it negative? Well, it's starting from here and it's down this way. So that's a downward pointing vector. That's my downward pointing positional vector, which means that that has to be negative. Okay? Now my initial position, if this point is negative 12, my initial position should be 0 meters, meaning at this point it's 0 height. Everything below it is going to be this negative distance. Now, what about velocities? Velocity initial and velocity final. Well, I don't know how fast it's traveling after that distance, so I'm going to leave it alone. And there doesn't seem to be any information to tell me how fast it's traveling in the very beginning. So I'm going to reread the problem and see if there's any clues in that problem that will help me answer that question. Well, so what we have here is how long does it take a golf ball to fall from rest a distance of 12 meters? Well, starting from rest. That falls from rest, so that means the initial velocity is going to be 0 meters per second. Okay? And I don't know time. That's actually what I'm looking for. Okay? Pretty simple. A lot of information there that allow me to plug into the right equation. So let's start with my right equation. Let's see what we've got here. We've got V final is equal to V initial plus AT. X final is equal to X initial plus V initial T plus, look at that, running out of space. X final is equal to X initial plus V initial T plus 1/2 AT squared. Managed to get that in there. And then my favorite, V final squared minus V initial squared is equal to 2 times my acceleration times, I'm going to use shorthand for this one, change in position. Okay? Now, I'm looking for time, so this does not seem to be a good candidate. So I'm going to eliminate that one right off the bat. Because I'm looking for time, that one goes away. Okay? So I'm left with this, and I'm left with this. Let's see what I've got. I've got acceleration. I've got my positions. I've got my initial velocity, but I don't have my final velocity. 2 variables, 1 variable. So it looks like this is the right equation for me. Okay? So up here, I'm going to start by writing it out. X final is equal to X initial plus V initial T plus 1/2 AT squared. Now I'm going to plug in my terms. I have them memorized, so actually I'll just write them down the side here for now. So my initial position was, or my final position was negative 12 meters plus, or is equal to, boy, am I going to have enough room? Maybe not. I'll erase these bottom two. Okay? My final position is negative 12 meters is equal to my initial position, which is 0 meters, plus my initial velocity, 0 meters per second times t. This all goes to 0, so we really don't have to worry about it. Plus 1/2, gonna cheat by using 10, not 9.8, t squared. Okay? So this term is now gone, this term is now gone, and I'm only left with these. So half of 10 is 5. I'm left with negative 12 meters is equal to negative 5 meters per second, t squared. Divide that out. I'm going to get negative 12 over negative 5. Negatives are going to cancel out. Should have done that initially. Second squared is equal to t squared, and then I just simply take the square root of that, and I get the amount of time it takes. It's approximately, gosh, I'd need a calculator for this one. I can't really do it in my head. That would be 2.2 or 2.25 dividing, taking the square root of that is going to give me about 1.5. So 1.5 seconds. Okay. So I approximated the time to be about 1.5 seconds. The second part of the problem is asking me how far does it travel if I double the time. It's an important little bit of information because most of us like to think of things linearly. So if I double the time, we expect the distance to double. That's not the case. Okay? So what I need is I'm going to have my information again. My acceleration is 10 meters per second, negative. My initial velocity is 0. My final velocity is unknown. My initial position is 0. My final position is going to be unknown. And my time is going to be doubled. So it's going to be 3 seconds. Okay? Going back, looking at my equations, V final is equal to V initial plus AT. X final is equal to X initial plus V initial t plus 1/2 AT squared. And V final squared minus V initial squared is equal to 2 times my acceleration times my change in position. Okay? Let's look at the first one. I don't know, I do know, I do know, I do know. So I can solve for the final velocity. Not really what I'm looking for though. I don't know, I do know, I do know, I do know, I do know, and I do know. This looks like a good candidate. Alright, last. I don't, I do, I don't, because I don't know the final position. So that means that the middle equation is the one I'm going to use. Okay? So my final position is unknown. My initial position is 0 meters. My initial velocity is 0 meters per second times 3. Oh, look at that, drop in my units. Plus 1/2 negative 10. I don't really need this anymore. Negative 10 meters per second times 3 seconds squared. Goes away, goes away. I'm only left with this. So position is equal to negative 5 meters per second times 3 squared, 9 seconds squared. Okay, 9 times 5. Well, that's going to give me considerably more than twice. That gives me about 45 meters. The seconds cancel off and I'm left with just meters. Started at 12, went to about 45. And why I'm saying about 45 is because I took an approximation on my time. I said it was about 1.5. It's probably a little less than that. Or a little more than that. Because this answer should be about 48 instead of 45. But nevertheless, that's how the problem is done.